Example 1. Find the slope of the line joining 2, 2 and 14, 7. Here on the xy plane we've got the point 2, 2, 2x and 2y, and the point 14, 7, 14 out and 7 up. And we're interested in the slope of this line. How fast the y values are increasing as we move out in terms of x. So if we look at the changes in terms of x, we're moving from 2, 2 to 14, 2, or a total of 12 paces. 14 minus 2 is 12. 12 steps from there to there. And in terms of y, from 14, 2 to 14, 7, we're moving from 2 to 7, or a distance of 7 minus 2, 5 paces. 1, 2, 3, 4, 5. And the slope is defined as this number here divided by this number here, or that ratio of the vertical to the horizontal. So the slope m is defined as 5 over 12. It's also, in terms of this angle here, this will be called the opposite, and this will be called the adjacent. Opposite over adjacent would be tan of theta for a 90-degree angle. But for the moment in the line we're calling it the slope. M is the change in y values over the change in x values. There's a general formula for this. We don't have to work it out each time with the numbers. And the formula is y2 minus y1, the change in the y values, over x2 minus x1, the change in the x values. And that ratio gives us m for every single line. Now, example 2, we're going to find the slope of the line that joins the points 2, 3 and 4, 6 without drawing the lines. So we're going to rely now on the formula. To do this, we're going to say 2, 3 is x1, y1, and the second point is 4, 6. So we'll write those down and keep them safe in a box where we will refer to them later. The equation we're using is given in the tables. For the slope, m, is y2 minus y1, the difference in y values, over x2 minus x1. And now we substitute, because we know x1, y1, x2, y2, we just substitute into this equation. So m is equal to y2, which is 6, y1, which is 3, so 6 minus 3 on top. On the bottom, x2 minus x1, well, the x2 is 4, the x1 is 2, so 4 minus 2. And now it's just arithmetic. 6 minus 3 is 3, 4 minus 2 is 2, 3 over 2 is 1.5. So the slope of the line that joins the points 2, 3 to 4, 6 is 1.5, without even drawing it. Example 3, a different line. Find the slope of the line that joins the points 3, 3 and 6, 1. We use the same approach. We save the numbers. x1, y1 is 3, 3. x2, y2 is 6, 1. The same formula. The slope is m, the change in y values, y2 minus y1, over x2 minus x1. In this case, m is equal to y2, which is 1, minus y1, which is 3, so 1 minus 3. On the bottom, x2 minus x1, which is 6 minus 3. So 1 minus 3 is minus 2, 6 minus 3 is 3. And this time we're getting an answer of minus 0.66. Well, it goes on forever, 666. But we're seeing that the slope is negative, so this line would be coming downwards rather than rising as we move in the positive x direction. Example 4. Find the distance from 2, 2 to 14, 7. Here's the point 2, 2 and the point 14, 7. And we're interested in how long that distance is in the shortest possible path, not going the long way in terms of staying on the x's and the y's. So if we look at the x change, we're moving from 2, 2 to 14, 2, or a total distance of 14 minus 2, or 12 paces. And on the y, from 14, 2 to 14, 7, we're moving 7 minus 2, or 5 paces. So that's 12 and that's 5. But because the xy plane is perpendicular, this is a right angle here, x and y axes are perpendicular. This here is also perpendicular. This is a 90-degree angle. It's a right angle triangle, so therefore Pythagoras' theorem applies. So the length of this squared plus the length of this squared should give us the length of this side squared. So using Pythagoras, 12 squared, which is here, 5 squared, which is here, added together and square rooted, turns out to be the square root of 169, or 13 units. So the length from 22 to 14.7 is 13 units. The general formula for the length between 2 points is given in your tables and your book. Is the change in x values x2 minus x1 squared plus the change in y values squared, all square rooted. So once you know the two numbers, you can find the lengths. So we'll do this now in example 5. Find the length or modulus of the line segment which joins the points 1, 1 and 5, 4. We're not going to draw the line, we're just going to use the formula. So 1, 1 is our x1, y1. 5, 4 is our x2, y2. So we keep that because we're going to use and rely on that. The length of the line segment is x2 minus x1 squared plus y2 minus y1 squared. The differences in the x's and the y's. And now we just substitute the values. x2 was 5, x1 was 1, so 5 minus 1 there, squared. And in terms of the y, the changes in the y values, y2 was 4, y1 was 1, so 4 minus 1 squared. 5 minus 1 is 4, so 4 squared. 4 minus 1 is 3, or 3 squared. And 4 squared plus 3 squared is 16 plus 9, which is 25. And the square root of 25 is 5. We don't use the plus or minus here because we're talking about the modulus, the length. And the length is always a positive value. So it's just the plus 5 that we're looking at there.